Dear colleagues, good day. I'm glad to open today's third part of our discussion, the panel discussion, staking at robots, stake at robots, drivers and barriers of manufacturer robotization. So we see huge new opportunities. At the same time, we see considerable challenges. All stakeholders actually see those challenges: state, business, people, general public. We see considerable changes at the labor market, at education. There are serious changes with regard to business models of the companies, and we'd like to discuss those issues with it seems to be the very competitive, very competent colleagues. And first, people I would like to call up. It's Anna Fedunina, representative of the Sky School of Economics, director of Analytical Center of National Research Institute. The boss apologizes. The speaker did not turn on her mic, so the translation is not possible at the moment. Hoping it will be rectified in a flash. So we talk about $14.5 billion, but there are more optimistic assessments which reduce this price 5 times. If we took with the market of industrial robots, services on software and production of associated components. So with such an amount of this market, the most optimistic fraction or portion for Russia is this market is no more than 1%. It's incomparable with part of Russia. It's global GDP, so 2.5 lower. And since the robotic production is concentrated just in several countries, we should also talk not only about the components, market-related components, but also we should talk about the import-related components. And with regard to the import, the global market of those robots, which are sold between countries, it's about $5 billion, and Russian market share is tiny. Russia imports only 0.6 volume of the global market of robot production. If we talk about the depths of robotic so to say, deployment in Russia, so it's about 4. By the date of 2019, we have about 4 robots per 10,000 of employed. It's in Germany it's about 400, but Russia has rather good development rates. During the last years, the number of robots increased 3 times during the last years, from 1.5 per 10,000 employed up to 4. So while China, for instance, is growing with 2-digit numbers. And talking about the components of robotization, then on one hand, when we talk about Russia, it's important to mention that during the last 10 years, the amount of investments into the of capital investments, it is almost 2 times ahead of the robot deployment as Russian assessment. So it's investments in a fixed capital or capital stock. So we should say the high rate of economic growth is related to the deployment of industrial robots. That's what's happened in China. We will see it next slide, and that what we do not see in Russia. And at the same time, I would like to mention that the amount of robot deployment out of the total employment in the fixed capital is tiny, and along with the rate in the beginning of the 2000, it decreased even 2 times. Talking about the robot production in the world, then first of all, we can see such explosive growth in China, and those four-digit, it's fourfold numbers of growth since the beginning of 2000. They actually coincide with the growth, with rapid economical growth in China, which showed 10, even 14% annually. And other countries, if you look at other large robot production, robot producing countries, they're growing, but it's rather modest. And to some extent, it could be explained with actually gradually slowing down economic growth rate. And Russia is incomparably small with other countries, comparing to other countries. If we talk about the second component of the internal market, meaning the import of the industrial robots. So first view, we could first assume that things looks quite positive. We can see that during the last 10 years, the rate of importing robots into Russia is growing, and the growing rate is ahead of total input of investment goals. I mean, all machines and equipment. But again, once again, we should get down to earth, and we should understand the fraction of input of robotic equipment out of the total input of machines equipment is extremely low. It's less than 0.05%. And it's kind of such a structural deformation, because if we look at some comparable countries, including post-Soviet countries and even developed countries, then for them, the fraction of robotic equipment import is essentially 2-3 times higher. But again, if you want to look a bit optimistic, I want to mention geographic import structure, because Russia is criticized because we import from the wrong countries. It's some kind of a wrong import. We try to find cheaper analogs, and that's why we look at other countries. But regarding to the robotics import, geographic structure of import is almost identical to the global pattern. So Russia, in that sense, purchases or procures robots as any other country from the same countries. For instance, we have Japan, which imports about 30% of imports, and we see Germany and Italy. And a couple of words, the difference of robot-equipped companies in Russia. It's from our review of various manufacturers. I would like to mention the conclusion, which we heard as the first section. Manufacturers with modern technologies, usually they are large and they're quite young, which shows a kind of a contradiction. But what else is important? Which companies which intensely deploy robotics also they more frequently need highly qualified personnel, and so you see that their fraction of highly qualified staff members is about 20% others versus higher versus other companies, and also they export more frequently. Usually it means export to the so to say Western countries. So we know that and we know that robots improve performance, which actually is a very important factor to enter the external markets. So we can see that robots they displace so to say personnel into production sites, and those production sites they improve their profits, and naturally it it resulted in enhanced performance in such manufacturers. And the last slide is about the following: what hinders this what hinders these factories to become, so to say, robotic equipped? The main issue that companies that deployed robots, they less frequently see any issues with digitalization, and to some extent we can say that manufacturers with robotic equipment are better companies. They have more of highly qualified personnel. They don't need to find specialists with specific competences for digitalization and giving assessment evaluations for St. Petersburg and Leningrad region. So the similar trend that we could see at the national level, it is confirmed for manufacturers at the region. I will wrap up there, and if we have more time, I will tell you a couple of words about the specifics of robotics deployment in various industries and about premium for robotic deployment. But I have a following question. How frequently companies use these technologies, robotics, but this talk, there is a question, how intensely we use those robots. We can use just one robot at some auxiliary production site and say that there is a robot used. So we are robotic equipped, so to say, for a company. But we are closer to the second model, because if we take robotics density, I mean, how many robotic complexes we have per one employed person, for instance, in car production industry, we're really delayed from other countries. So they use robots, but how intensely, how deeply they're used in the production process, it is a matter for discussion. And then now we're going to have a talk by Mr. Alexander Pavlov, head of the Department of Digitalization and Remote Monitoring Center of Siemens Technology gas turbines, digital twins as a basis for robotization of technological and manufacturing processes. Why I made kind of an introduction before that? Because here we're going to talk about quite deeply deployed robotics into the company business flows and production flows. Thanks a lot, Vyacheslav, for very good words. I would like to thank organizers of this forum for this opportunity to make the talk. It's a plenary session. And first, I would like to start from a short, so to say, presenting our company, Siemens Technology gas turbines. It's energy and equipment building manufacturer, and it's a joint venture of two giant company. It's a joint venture of two giants. It's Siemens and from Germany and Power Machines of Russia, which has 35% of stock. So we sell service maintenances for the high power gas turbines. Also, we started to produce components for green energetics, and quite recently we provided another set of equipment for another wind park in Russia. So let's come to the topic of my presentation. I would like today to share with our experience and in general with our understanding on how robotics might be implemented in the dimension of, so to say, being based on the technology of digital twins. You know, the digital twins, it's a differential model of the end-object in the virtual environment, and our company actually, when assessing, evaluating, and discussing this notion, we suggest to get a bit abstract and enlarge and expand this definition. We prefer to use such notions as digital twin on diagnostics, on operational use and maintenance, and virtual digital twin. And all those twins, they have one main task, is to target on maximum effectiveness and performance, improved reliability, and protection of the equipment use. We don't talk about equipment only as a local site. We talk about the equipment used at our customer sites. I mean, gas turbine or steam turbine, so to say, units at the sites of our customers. So, what is a diagnostic digital twin? It's tasked to improve reliability through permanent monitoring and trending the data, analysis data in the joint digital environment. It could be made either in the real-time mode or using even mobile electronics. Talking about the diagnostic digital twin, we should not forget about predictive analytics element. This predictive tool is made to forecast in preventive manner potential deflection, potential deviations from, so to say, from regular normal functioning, and to avoid emergencies, to prevent accidents. So all those efforts on preventive analytics and preventive diagnostics, they are based on artificial intelligence. Then a couple of works about the operation and maintenance digital twins. Well, in the context of production equipment with a 3D mass model, in the context of the use of the gas turbine unit or mass model, we optimize function of a specific unit, and thus it makes possible most effective manner to use the equipment being in the workshop or in some other area. And we shouldn't forget that in our modern realities, in modern life settings, the issues related to the remote support for operational use, with remote maintenance, this issue stands to the forefront, and that's why when we talk about the operation and maintenance digital twins, we discuss use of the equipment in the remote mode up to the autonomous use. And virtual digital twin is this 3D copy in virtual environment. It's not just a 3D model, it's a data information carrier. So this model might have the use guidelines. Along with that, it might contain real relevant parameters. It might contain real parameters of the equipment function. Along with AI, it might provide some predictive analytics functions, and thus in the virtual environment, we can track from any point of in the world how the equipment is used. And I should repeat, all these digital twins, their task is the most optimal, the best possible use of resources, its modes of functioning, and improved reliability. And continuing the topic on staff protection, I would like to show you several so-called referent cases. For instance, robots, which we use to inspect large generators. Just a couple of words. When we need to inspect large generators, there is a big need to remove the rotor from stator. So it's quite a labor-consuming process. It takes lots of time. It requires high qualified personnel, and it bears the risk of damaging of the human of the worker if he if during the removing of the rotor, if he start if he takes if he touches the so to say winding wires. Yeah. So with new technology using the fast-twitch robot, robot gets in between rotor and stator. It could be programmed to do inspection on its own, providing images to the operator. It has also AI capabilities. So we don't need to remove the rotor from a starter, first to say. So it can identify such serious defects, or this defect could be skipped up to the next stop. It's an important function, and the robot is used in the remote or under the remote control or even autonomously. And the next project implemented our own production. It's our own workshop, having 3 production lines. It's line on mechanical process of the details of the rotor group. It's a line to line for welding and mechanical processing of details of the stator group, and final assembly of rotor and the entire gas turbine unit. It's a 3rd line, and all these lines, it's our production complex located in the Gorelova. So it's a well-known KUKA robot. It's using a bit of a non-conventional component it's used for laser evaporation or coating for the special coating to on, so to say, the details to provide wear resistance, and when we thought about how we can simplify and this process, we came to the digital twin technologies. So we programmed this robot using virtual digital twin technology with logical programs, modeling scenarios for development of production and manufacturing cycle. So minimize number of operations to tune up the equipment. After that, we have only one operation on, so to say, equipment, so to say, alignment, and then we can do this laser covering of this wear-resistant layer. So the next is a full-size robotic training or device or simulator, which has an original interface to control this steam gas energy unit. It's fully emulate this unit and makes possible to imitate technological processes, not affecting the final object. So why do we use it? Why do we need it? First of all, it is used to train the staff. It can be used to test algorithms, and these algorithms from different types could differ based on the types of the gas turbine unit. So it's very important as a specific algorithm to work on those specific algorithms which will be actually utilized. Another important issue is that we have complete backward compatibility, meaning that when as a simulator you work on some technology, you have a feedback from the controller. So if something is erroneously programmed, if there is some improper technological chain, you will have a feedback immediately with a message that, dear user, your actions are wrong, and it indicates what was done wrong and what are the options, what are the potential options for the events to develop, and how to, so to say, rectify the situation. And another important fact is that using this simulator, we can model, so to say, non-conventional and emergency cases which might happen at the, so to say, real production energy unit. And I would like to mention that in the context of considering robots as an integral part of digitalization process, they have several advantages. Here we see most, so to say, major of them. So first of all is boosting of technological processes and technology, and also you can boost we can boost, so to say, development of the technologies due to the preliminary imitation of the workflow. Second thing, and modeling and development of scenarios for technological equipment or workflow using pre-programmed algorithms, using along with smart technologies and AI. And another very important factor is remote control of this complex up to full autonomous activity. We can prepare it, so to say, we can load it with a preset of ready algorithms, and then the robot automatically will provide us with all necessary technologies. That's briefly what I want to share with you at the beginning of the discussion, and thank you for your attention. Thank you.
Могли бы не убегать, я вам один маленький вопрос задам, а потом мы уже пойдем по нашему обсуждению. Вот смотрите, очень интересно вы рассказываете, причем понятно, что это практика,
It's very
она
interesting
живая, реальная.
what you are telling us. It's a real practice, but to what extent it is interested by other enterprises? They are speaking about digital twins, and but are they aware of what it is? Yes, we have been discussing this a lot. In fact, many of our speakers have already mentioned it. When we start demonstrating all the advantages of digital products implementation, smart technology, initially we do have a question from the supplier. What is the cost of your solution? What is the price for it? And we start actually calculating the business case of its implementation. We start calculations, but at the moment, all these digits, all these figures show that there is no trust. The trust is very weak. And within this field, of course, we need to continue developing this issue and somehow negotiating the message to the final users. Yes, thank you very much. Now, dear colleagues, let's move on to the discussion. We see several rounds in this discussion. The first round is when I want to almost all the participants, ask almost all the participants, to what extent these are that technologies, robotic technologies, are popular and widely used in the Russian enterprises. Do they correspond to the world practices? And whether the process of divergence are used. So when some enterprises are better even than some European enterprises, and there are other enterprises which are far away from automation, or there is some convergence actually, so they merge in terms of quality. And the first person who I would like to invite to take part in the discussion is Mr. Kapeshnikov, General Director of KUKA Robotics in Russia. And a beautiful word, as KUKA has already been mentioned by Alexander Pavlov. So the floor is yours. So, to what extent our industrial enterprises of St. Petersburg are robotized, whether the best practices are still in the future or they are the matter of present, and whether they are homogeneous. Good afternoon, dear ladies and gentlemen. The situation in Russia, just like you already stressed in your analysis, is quite unfavorable, because out of 4 robots, we at the moment use 6, and the world level is from 99 to 110. So by 20 times we lag behind, and we continue lagging behind because they continue growing, and we do not have this exponential growth. So the Leningrad district is one of the leading regions. The most breakthrough is Tatarstan in Russia, in terms of the use of robots. In Tatarstan, I would say they have correct industrial policy. They scrutinize the best practices from abroad and try to implement them. And robotic technology, at the moment, is next big thing by the report of the Savings Bank of Russia. This is a breakthrough technology, and everybody in the world understands that it must be supported. In Russia, we don't have such big support. When it comes to the Leningrad district, I suppose there is a great support of the foreign enterprises who are represented in the region. There are many colleagues who are present here, and they have brought with them the culture of automation in 4.0 industry, and some of the Russian companies have to meet the standards in the region. So divergence, I suppose, this is something that we can observe in Russia, coming back to your question, because the companies, they strive to be digital and robotic, and they are more successful, and they start actually winning over other companies in this competition. Those companies who don't deal with that, they actually lag behind, and such examples are multiple. There are many. And those companies that don't use contemporary technology, they lag behind. May I ask you, right from the very start, what can be done for these practices to be more popular and more widespread in the economy of Russia? So first of all, there must be state support, because even in Sweden, where robot technology in popularity is much higher than anywhere in the world, even they have a program on supporting robotic technology. So China, United States, Europe, America, they understand importance of robotic technology, and they set this movement forward. This is correct approach. At the moment, we don't have it in Russia. Second is education. Our education in terms of robotic technology, some 15 years ago, as we saw it, it was not 100% correct, and we can compare it to the European, because actually they were taught to use the robots, and we were taught to construct robots, and they were taught to use them. But in Russia, we do have the breakthrough, some breakthrough. So these are the main two factors: state policies and education. Thank you. Now, I would like to ask the same question to Mr. Gavriluk, President of Termes Corporation. How do you assess robotization or robotic technology use in the enterprises of the Leningrad district? And how do you see the social and economic effects? Now I can hear. So, I'm not Gavriluk. I'm Alexey Lysenko. I'm director of corporate department. I'm just a replacement. So it's very good that business works 24 hours, 24/7, and the person, Mr. Gavriluk, just was unable to come. But that's a good business parameter, as you can see. So our history. Okay, a couple of words in a nutshell about our situation, about the story of our company and robotic technology. In all the industry branches, there is some motherland of technology or history of a brand, like in car manufacturing, we have the big three companies, and the Termex is an Italian brand dating back to 1949, which was born in Italy. So when we started our company in the Leningrad district, that was localizing the production. So Termex selected Leningrad district thanks to the team of Region 47. If we had the same choice to make now, we will choose the same region again. So Termex localized in the Leningrad district, and starting from 1995, when it came to the market, and up to the 2000s, Thermix actually moved from Italy to Russia, and in 2016, actually, we moved back to Italy as a Russian producer. And the Italians were very much surprised, because Thermix, they continue using the old appliances by Thermix, by that Italian Thermix. So we live in the paradigm when we consider that the main object of management is cost, which is something that is calculated at the project design stage. So when we start localizing, then the plant starts to be designed with the use of the most state-of-the-art practices in this area. The main designer was Mr. Silvano Tamburini, a person who has approximately 10 water heating plants all over the world. So we are very lucky that we are a diamond in his gold collection. There were a lot of innovative things and mistakes corrected when he designed our plant. At the moment, automation level is 90%. That's an automated, fully automated plant. So this necessity, in fact, was initiated at design stage, because this is a highly competitive market. Otherwise, it is not possible to compete. So, as a matter of fact, we decided to be designed as an export-oriented enterprise, and we started exporting technology later on, but that's a separate issue. We shall be discussing it later. We can speak about the fact that robotic technology is not a panacea always, and there are negative aspects of it as well, applying it to this or that business model, because we have plants not only in Russia, we have manufacturing sites also in other countries of the world. When it comes to the Tosno plant, which is the biggest full cycle plant on water heating systems in Russia, this project would have been completely impossible if robotic technology was not fundamental to it. Thank you very much. And now, dear colleagues, Vasily Burov, is he with us already or not? Not yet. Okay, please give me a notice when he is connected. Okay. Now, I will try to readdress this question to Dmitry Evgenievich once again. If Vasily is not with us, he is still part of some important competition and he cannot be part of our discussion. My question is the following. In terms of the effects that I've been asking about, whether thanks to robotic technology there is a transfer of principles of activity from one type of activity to another. What do you think? That's a good question. I mean that it's quite a complicated question, quite sophisticated. Of course, the transfer is quite difficult. Medicine, for example, when industrial robotic technology has never been used, at the moment they use it actually, and from machine building, from car building, they use some technology already in medicine. If we speak about food production and car manufacturing, well, yes, for example, matrix production, something that is a good trend, a paradigm of 4.0 industry. In fact, it was derived from automobile production, and the conveyor belts at the moment are being replaced by AGB. So these conveyor belts and the robots actually are doing something. At the moment, there are robotic cars which move the product about the plant. And there are many technologies which are derived from the car manufacturing. For example, in the United States, they construct planes by the same technology. They assemble it, and there are cars actually that bring all the components to the site, and it's just a different approach to organizing to the in-site logistics. And to what extent industrial sites, manufacturing sites are robotized fully or not? Whether it's far away until we reach the best practices or not. And it's a question to the executive director of Nokian Tyre, Boris. And it's not a question about whether these practices are good or bad and whether they are really popular, but what are the effects of this robotic technology. As a matter of fact, we are very close to world practices. I suppose that world practices sometimes should be looking at us as an example. It's been 16 years of our plant today, so it's happy birthday of our plant. Nokian Tyres was started as a relatively small tire enterprise, so within 16 years we managed to evolve, and the result of these 16 years is, so to say, at the moment, we are the biggest tire enterprise in Russia, the second in Europe, and one of the biggest in the world. Within these 16 years, we have been growing rapidly. Every year, almost every year, we enlarged our capacity, production capacity, and every stage of this expansion, all the investment that was made, it was the company recruited the state-of-the-art technology. We do not classify them as robotic and not robotic. It was just the top-notch. So this and in 2021, we opened up a new warehouse, which Alexander has already referred to. So if we come back to what we are at the moment, so this is the plant with the investment of over 1 billion euro. And if we speak about this, density of robots or something like that you mentioned. So 1 billion euros at the moment, we have approximately 450 people who are our employees, and such indicators as so we have the turnover is 17 million tires. We are the most highly producing plants in the world. Whether we are close to the world practices or not, we are one of the leaders. And the robots are used at all the stages of the production process. I'm not even going to quote. And the trolley technology that you talked about, these trolleys that you were talking about previously, we actually started that 5 years ago. At the moment, we use 12 HGV trolleys. They carry mixtures between the mixing workshop and other parts of the production process. And as soon as you understand how all this works, you continue just and start using robotic technology. We don't even know what to robotize further, because today during one of the sessions it was said that the level of professional capacity or qualification of our personnel is very high. So people who work in Nokian Tyres, they already have ideas of what to do, and the technology is, we don't have the technology. We have the ideas, but we don't have the technology for it. As soon as the technology arrives, we shall implement it. And in conclusion, just a couple of more words about the warehouse. This is a unique project for Russia, but not only for Russia, because it is just unique for the tire industry of the world, because it's not just robotic technology used, because everywhere in the world you can find robots in the warehouses. But the unique about it is that the We don't stack them in pallets, but we store them in tires. Each tire has an address in the warehouse, and when you assemble the order, the robots actually use these addresses. The square capacity is 17,000 meters, 550,000 tires are stored there at a time. So, and with these addresses, in 1 square meter has the capacity of twice as high than a usual warehouse, and actually decarbonization can be said that we can say that the decarbonization is one of the good outcomes of this particular approach. When we were dealing with automation, nobody thought about carbon footprint, but it was just a very good byproduct of this project, and there is only service engineers who just monitor the system. So robotization is not just the technology of today, even not the future, not today. It's the technology of the past. We need more newer technologies to implement. Thank you. Now I would like to pass the microphone to one more participant of our discussion, Vladislav Dioev, who is the head of our Technological Process Department of the Production Developments. So these technologies, are they really popular in the business enterprises or industry enterprises of Leningrad district, and what are the effects? So, dear colleagues, thank you very much for the question. If we speak about our production sites in Strelna, I would say that the level of robotization is 4.7%. That means the number of robots if compared to the number of jobs. If you look at the best practices, the traditional for our business, Germany and Spain, level of robotization will be approximately 21%. In Turkey, it will be somewhere in the middle. It's 8.9% approximately. From the viewpoint of social viewpoint, automation of gluing process, for example, is very important because glue actually, despite the fact that it is considered to be absolutely safe, nonetheless, we need to heat it, and there will be smell coming, so it's quite hazardous for the personnel. So such type of processes, of course, must be automated fully, without any participation of labor force. Apart from the social benefit, it will also give us better quality and better reproducibility of these processes. It will be much more efficient than just a regular way of doing it. So we have actually had a good round discussion, and I can sum up by saying that there are really good practices in Russia, in St. Petersburg, in the Leningrad district, when at the global level we don't look really bad. But at the same time, there is great divergence, and there are many companies which are not involved in the process. So in the next round, I suppose, we should discuss the barriers. Why some companies are lagging behind and they are not ready to catch up with the leaders. When we are speaking about the consequences and effects which we witness, I would like to ask a question to Anna Fedunina as an analyst and a researcher, whether we can get some averaged estimations. What the company gets for using robotic technology a lot, for automating its processes. Yes, indeed. It's an interesting question, and as far as I see, in 3D, we can evaluate this particular benefit, productivity, size of an event, whether these companies are bigger or smaller than non-robotized ones. And the third criteria, which is related to the previous two, is the criteria of export activity. So if you go one by one, on average, the enterprises that use robotic technology, approximately 1/3 are bigger in size, and the effects are different in terms of the branches, like in chemical industry, for example, machine building and equipment production. The effects are twofold. So the enterprises are twice as big as the ones without robotic technology. So most probably, if you come back to divergence, they are the divergence is very important. But where is the reason and where is the consequence? Maybe for the bigger companies, robotization is more, so to say, typical, or vice versa. Can you respond to that? Yes, I can try. I would say that there are not so much data, and it's not very easy to evaluate this. What I know for sure is that robotization helps us to grow and to improve the productivity in very difficult areas such as textile production, clothing production. Such growth, in fact, is reached by such growth would be 30–40% within a decade. Like, for example, textile the growth will be several-fold as rapid. I mean that the simpler ones, the simpler enterprises will actually grow faster. Yes, no, I don't speak scientific language, I'm sorry for that, or academic language. Now, do you have anything to add? What are the benefits that an enterprise can get from a robotic technology? Well, as a matter of fact, there are several. It has been said several times today that we can connect robotic technology with better output and export, but we do not witness this in a number of enterprises. For example, food industry, food production, rubber, construction materials. We can see that those enterprises which are robotized, they work for domestic market more, and they actually are not going to go outside. I see. Thank you very much, Anna. Now, dear colleagues, can we move on to the next round of discussion, and let's try to understand what the restrictions are. If we speak absolutely frankly, then there are restrictions, objective restrictions. For example, it can be some sort of excessive social restrictions and the jobs, for example, that would depend on robotic technology in car industry. And if you, for example, if you actively push the robotic technology, then how about jobs? And how do we implement it? Maybe it is different at the moment, but do you remember this story with the Moskvich? For example, there was robotic technology implemented on welding, and it was beautiful, but the quality of welding was not optimal, and they needed to actually smoothen it manually, and then actually, again, they needed to color the car or just coat it also manually. Is it a complex approach to robotic technology, or do we just mimic this robotic or fully automated cycle of production, like in the situation with Moskvich? Like, for example, there is a wonderful robot that actually is switched on only when the director of enterprise comes with an audit. Or robotization is something that is absolutely mandatory and something that really is needed in each company, each section or segment of business. I love this, royal path. or royal audit that you said. Okay. Yes, indeed. Sometimes it happens like this. Indeed, there is a royal path for the Tsar to walk along while making an audit of an enterprise, and somewhere in remote areas, robots do not work. Well, indeed, it does exist. There are state contracts, and when in this area we have great competition, then they will actually be forced to think about how to increase efficacy and how to bring down the cost. This is one of the aspects. But if we speak about larger enterprises in private sector, when competition is very high, we conducted a survey some 4 years ago. I suppose that was by the Ministry of Industry of Russia. And approximately 30% responded that the main barrier is lack of information. So companies virtually don't know about the robotic technology and how to use them. I can speak for my company. I had a bright situation when we came over to an enterprise which was working with the solid mixtures, and they were just doing it manually, loading manually. We were prompting about the robots, and they were surprised. That's lack of awareness. They simply didn't know anything about the technology standing behind it. Okay, thank you. Alexander, what would you say? Do you have any comments? Can you hear me? Well, just to continue what you have mentioned, one of the main barrier or resistance to the implementation of robotic technology is, of course, creating jobs, and I would develop this and add to this concept. What are the main barriers? Well, I suppose it can be internal barriers of a company or internal processes in this or that company, and it's not from the tops of the company, but from regular staff. They ask me, okay, dear, you are going to implement robotic technology, and what shall I be doing? Shall I be laid off? You will need to explain. Robotic technology doesn't mean laying off people. This is retraining. Retraining you as an employee. That means developing. This is something about mentality. We need to change the mentality. But could you kindly give us more example? Retraining. There was a manual, absolutely manual work that a person used to be doing, and if he is reprogrammed, retrained, and the person is of advanced age, is it okay? Yeah, that's a good question. And indeed, this is something that enterprises come across when they implement robotic technology. But I suppose there will be a way out. And the most important is raising awareness, having information, and also not leaving this person alone or laying off personnel. But just like a tick, I would like to say that such practices should definitely be shared, because people feel very well something that there is no solution, and who will be looking for solutions. And it's not clear, in fact. We're going to speak about barriers to robotic technology further on. And could you share your opinions? What about the idea of digitalization? Digitalization of a company will bring down bureaucracy and make company flat. It will combat hierarchy. Can we observe similar thing when we speak about robotic technology? I would like to ask this question to the Thermex company. Yes, thank you. I will continue this idea, the idea that I have already mentioned. I would say the following. Sometimes it's not just a barrier to to the use of robotic technology. I suppose that the main measurement is the success of a corporation or a company. We have 20 enterprises, production sites all over the world, and we usually judge them by general efficacy. It happens so that the business model is in itself is a barrier. And it's impetus for implementing different strategies at different stages. In Russia, we have fully automated production. In Turkey, it's different. I remember your talk a year ago about reshoring and the final customer, and actually we are very well matched with this trend. I was giving you a round of applause while sitting and listening to you. This is something that the market pushes us towards. Otherwise, we will leave the market. We have approximately 500 SKUs in different thermal equipment. We have completely different state standards that we need to meet. Everybody understands the sockets and the difference between Europe, Russia, and Turkey, for example, and Latin America. There are many nuances and petty details which are taken into account while production site is planned. So this flexibility in production, in fact, allows us to be customized for different sales channels, structures of sales. So selling it here, the gas boiler here in Russia and in Turkey, it's different. It's completely different sales, so to say, system, sales plan with a completely different marketing even. Of course, it would reflect in our strategy for our company, for example, when it comes to robotic technology in Russia, in thermal equipment. So even the boxes are being assembled by the robot here in Russia. But if we speak, okay, we are speaking about the electrical or just water heating. If we speak about boilers, gas boilers, the market is 100 units here, and in Turkey, 3 million. You can see different situation, completely different. So in the very last example, which we are proud of, back in 2020, we started production of thermal pumps. And this is technology of the future. This is completely green. When the system is quite complicated, when you take excess heat from different environments, from the soil, from the air, and we turn all this into energy for household with great... At the moment, we use it in Tosno, and it has great efficacy or thermal efficacy. And I would like to say that I'm boasting a little bit. Maybe it's not good, but it's a good example to what I'm speaking about. So we have a number of different awards, and we are quite competitive in this absolutely mad competitive market. So it's madness to create thermal pumps production robotized. Otherwise, you will go bankrupt. It's completely different focus. It's quality. It's about quality. It's customized. There are super genius machines which can take 100,000 live tests for every component of this thermal pump to continue working and to be resilient. Yes, contemporary technology are used, but it's not about robotization. That doesn't actually mean that there is a manual worker with a screwdriver doing something. No, it's automated, but it's not fully robotized because it's much more, so to say, sophisticated. And there are robotization is in different vectors. For example, it's training of personnel. Alexander said a lot about it. So today, in Graz, in Austria, there is a World Skills Championship So the United Team of Russia is actually represented by our company. We're very much proud of him. We are leaders in the market, and we have created an ecosystem of upbringing the new staff. And I suppose that it's reorientation to different things like staff training. Thank you very much. Alexander, I'm going to give you a chance to speak. And so I would like to touch upon another aspect, so readiness of the aspects for robotic technology. That example with Moskvich actually was a good one, because they were, it was not a question to robots and robotic welding, because they were just automated, but the staff was not trained enough, and I suppose that's one of the barriers to. Yes, you are quite right, because there is nothing worse than digitalization, which goes by the business processes which previously proved to be ineffective. It just turns them into such a plane that it would be much more difficult to get rid of mistakes. And there are sins and problems which cannot be changed and cannot be so to say, corrected. And the bigger the company is, the more difficult it is to change business processes. And here comes the question of whether there is a new paradigm in business to make it more flexible, more adaptable to change.
Since it's clear, today we have one model, tomorrow will be another, things changing rapidly. Alexander Yurich, could you comment something about the limitations or hindrances? I would like to focus on two things. It's about the staff. So we grew and grew with every next year, and when we started this EG, we have 12 in production and 6 in the warehouse. So for all those 16 growth of grow in the company, we did not fire any of our employees because of some internal reasons. And when we started to talk about the EG, started to so since the production, as I mentioned, is 1 billion in our factory, we have workplaces where we can in our company, at our plant, where we can retrain our staff members. They were retrained as operator for another equipment, and it's not just equipment to work with just with a screwdriver. During the tire production, we don't have any, so to say, manual work tasks. Everything's done with robots, and we retrain them. And the training of the staff in the country should be a separate session. It's a separate issue. But in our factory, we created our own training system, and we take people from the market, and they train through all theoretical and practical trainings. Those 50 persons, they were all retrained. We did not fire any one of them. They found workplaces. We continue to work with ECG and all the employees. That's the main notion about the staff. And in the future, I think the future still will be a problem, because if robotics will be rapidly developing in Russia, surely there will appear people requiring retraining. And I think we will not avoid state support, governmental support, because this problem cannot be resolved within the framework of just one company. It's not mandatory to train the staff with another technologies in the company. There are other places, other workplaces, other technologies where people could find nice place for themselves to get involved in some other industries. So the state should think this system for retraining, re-education to find some proper solutions. That's about the staff. And about the limits. I would like to talk about the bureaucracy and the flat structure of the company. So what I can say is that once our employees don't do any robotization, and we have lots of interesting projects, we're getting into the digital system for work process management, and our staff members, there are lots of opportunities for them to manage production processes. And if before those traditional approaches where once the management decides and employees, so to say, follow the orders, and once those people get access to this database, and I wonder, we have contacts with people who just start to take this data, which were accumulated for 5 years. It was very hard to take them. Now they got the direct access to this data, and they start to create extremely interesting things. They don't need any managers, so to say. They prepare not just a system of reports. They see problems in the factory on their own without any managers. They find these problems and they resolve these problems. And this flattening of the structure, we can see it in absolutely organic manner, not from above, but they go from below in a very organic manner. And thank you. And we touched upon, actually, we do talk about that all the time, but still we touched, let's say, we started to discuss the relationship between digitalization and robotization. So I'd like to ask for a short comment from the side of Alexander Yurievich. So from your point of view, digitalization and robotization, is it possible to deploy robotization without digitalization or not? Well, it's a good question, and I'd like to express my opinion, but I think it will be similar to the opinion of majority of us. I think digitalization and robotization is two, so to say, inseparable things. Digitalization without robotization is impossible, or it will be really limited. And talking about digitalization, I'm talking not about the manufacture automation, but I'm talking about the implementing smart technologies and modern model, so to say, methods. For instance, if we talk about technologies, we can talk about the artificial intelligence or added reality. And about the methods, it's a complex approach to digitalization, but the task is considered, so say, from all points of view, and there's perspectives not to use not only at one place, but you can say multiplying this experience. And as I mentioned in my talk today, our company, Siemens Technology Gas Turbines, which is a very bright representative of the international corporation at the regional level, we actively implement these technologies, and with a great pleasure, we're ready to share our experience with our colleagues. So, dear colleagues, and the last round, of course, we can infinitely discuss those questions. I'm really interested. I don't know about you. I can do it, but still we are limited with time, so there is just last round. I don't want to ask for a complete solution for you, but let's say there is a question: what to do? Just give us one main important measure or intervention. Say, I don't think it's right. We should stop and should develop the basic set of measures, because they would work separately on their own. They should work in complex. But if they say 60% of measures are implemented, but maybe there will be 40 would be left, without which it would not just work. So from that point of view, which measures here you think might show synergy? What is actually important? What should we do from the very beginning? Maybe stressing on what could be done locally, because here we have our own capacities, and sometimes we can do things which could be done even stronger, with a stronger promotion of those advanced technologies, and of course. I'd like to ask the first question to Anna Fedunina, as representative of the economics, because things started always from that. Let us, someone from the economics will tell us what should we do. Once she starts to talk, they say, "Oh no, it's something wrong, it's something not right. Let's search for some other approach." But since I also consider myself as a person of that cohort, so there are sometimes could be some serious solutions that we should do something. So Anna, please, we'll listen to you. Thanks a lot for such a good question. It's not what preliminary prepared question, but I think I might like to expand this question. It's extremely hard to say a specific intervention which would help. But I should draw to attention that looking at our studies and investigations, there are lots of factors feeling no incentives for digitalization, robotization, development. They feel themselves rather comfortable at the local market. So to those questions you asked, I would add another question: how to steer this swamp, how stir this factories which show no interest because of no incentives are actual for them, and the issues with there is an issue of providing information because people might not know about that. On the other hand, the local monopolists on some small markets, they feel quite comfortable, and to some extent they don't have any objectives to enter large markets, meaning it's not just the developed markets of the developed countries, but we talk about entering regional or national market. And about 5 years ago, we had one survey for small or mid-sized business in the Leningrad region, and we just wondered that among that cohort of entities, about 60 or 70% of them were those who said that they work only at the local market, meaning within the very not that, so to say, not that large market of the Leningrad region. So there is a big task how to stimulate the manufacturer, the entity, to start digitalization, and this is a strategic task which should be discussed and considered. Okay, actually, I want to say what should expect those companies that are not focused on any growth. And I think my colleagues, for instance from Nokian Tires, might say that if they have any competitors in other regions, do you have small competitors, like small business competitors to you? No. I'm thinking about that because once you used to be quite a small company, but you automated your production, and now you have no competitors. And so competitors which look at their local markets and they do not think about growth, they will just disappear. And answering your question briefly, my opinion is I'm a supporter of such an approach. First, let's see what's going on in other places with more advanced technologies or more advanced markets. Then we should analyze the situation and adopt it to our situation, to our case. And from our point of view, of course, we should check which measures on, so to say, on improving awareness are done in other countries. We know the measures, we know programs, but could you mention the most interesting measures or programs? Well, at the regional levels, it's one of the regions of Russia. I would like to start so-called technological audits regarding robotics. So essentially, we took completely the program, which is currently implemented in Sweden. It is well adopted and tested in Sweden, and the corporation which are involved with that, they're ready to do it. And this program works in their settings extremely well, and would like to translate it into our settings. So good, great, thank you. Thanks a lot. Alexander Yurievich, what can you say? Well, I'd just like to continue what the previous speaker said, that in order to push this process, we need to organize kind of a consortium or alliance of the suppliers of those robots. Maybe it will help to do the kind of a jump start or to drive it from the deadlock. Well, aren't there any associations? So can we have business association? In any association of the robotics users. If you ask about the Siemens gas technologies, we are not members of such alliances and associations, and no one invited us to be members. But because, of course, we are ready to share our international experience and multiply it if necessary, to help to bring it to other manufacturers. And that's why I'm suggesting to organize such consortiums. And it will be great if done under the edges of the state or regional government. But it's good if the state is involved, because there are different points of view. Because on one hand, the government or the state enters the situation, help to resolve the problem, and gets away. They are not involved into the solving the issue. In Russia, there are lots of companies which shall listen only to the state. And with robotics, we see that exactly. We see exactly that trend. With robotics, it clearly correlates with the advice of the representatives from the government, because it looks to be like it's not market instruments do not work, but the administrative mechanism actually really works. It's a great example of the Industry 4.0. It's a state public-based program in Germany. I think the state must have the leading role to set the vector and then let it develop. But the vector should be set from above. But the program 4.0, it's a program about standards. It's a program about the standards for external users, to promote the standards to the global level. So the next comment. So you're done? Yeah? Yes. Okay, good. Next one. We suppose, besides the cost of the product, we think about our staff. Briefly saying, we should involve young people. We should fight for young people. We should make them. Be desirable. We want to see. We see them to be highly interested in modern technologies. We have a great experience with cooperation with ITMO University. At the stage of the factory design, we found very interesting connection points. They help us to design robots and other issues, and we had some basic department, and the department changed or was transformed into a research and scientific laboratory of robotics. Since 2014 and 2015, I personally took students, trainees to our factory. I saw towards this set, saw their eyes shining. And they said, come on, oh my goodness, what kind of factors can be in Russia? And it is Tosno. Come on, I saw, that's you nicely expressed what said. There were lots of emotions. I heard it myself when a person said, they let them play with the manipulator, and the eyes just got wide and shining. So as a company representative, I can say that we built a corporate spirit on that, some kind of a corporate philosophy. And I think, from our side at least, we are looking for these points of growth in involving young specialists with shining eyes. And about this small part about the state, I could say, Region 47 has multiple means of support, and we do communicate here because we're here as a conference organized by the team of the Region 47. Always we can say that we want to have something more, something could be added. But for instance, when we talk about production means, and the presentation, which you said, this means of production. Italy is a third place. It's about us, because it's motherland. It's so to say motherland of so to say water heating business, and it was times when the Soviet Union had a very important role in the so to say equipment production and means of production, and maybe we hope someone can do it better than us. So, two more comments from your side, Alexander Yurievich. Just for 1-2 minutes. What to do? What should we do? It's a well-known Russian question. I looked at that because here we have just large business, and there are no big issues with robotization because there is a kind of an internal stimul. It's stimulates quality in markets. More than 50% of our products they are exported, and without stability and quality, it would never happen. And it's not about the large business, and maybe not about the small business, but about the mid-sized business. And if it would be a great stimulus for the mid-sized business in the country, if the markets, the company internally thinks about growing, they have the requirement for growth, but they have some market-related limitations. And if the limitations are removed, it is possible, if there is such an opportunity to provide some assistance to some diamonds of the mid-sized business to the European market and expand their sales territory, the requirements to the quality and stability, they will automatically and organically result in the following. The company will say, for make this quality stable, we need to automate this process. We need to provide robotics to this process, and it would not be some kind of external, pushing from a side. Place it and try to do it, but it will be internal desire of the company. We need to produce good, high-quality products. We should win at the European market. We need stable quality, and with that internal stimulus, something would happen in a global sense, and gradually, slowly, all the technologies on automation and robotization, they will come to the mid-sized business. Well, as far as I understand, those efforts of INEC, they had special efforts to support hidden champions, mid-sized companies. So it's from Ministry of Economy. It was from Ministry of Trade, Industry and Trade. They have also a federal program. It's for mid-sized, but it was a good program. They talk about the contribution of small and mid-sized business to export. It's subsidies, and they have quite considerable subsidies. It's a very good support to the Russian exporters, exporting the product to the Europe. Then they understand that in Europe we can overcome some competitors, and this internal desire for robotization, it will emerge. And Ruslan Vladimirovich, you are, so to say, you can say the conclusive words. What should we do? Well, about that, as it is said, robotization today mainly is an issue for large companies, and it seems to me the problems of small and mid-sized companies is that business processes are not finalized. They should go to the lean production, to the production systems like Toyota and Bosch production systems, and then it will be clear and it will be possible to do robotization. And the most final idea, well, from the point of view of the population involvement, if we think about switch from the agriculture component mechanization, lots of people were freed. So they used to, for instance, they used to work with spades, the shovels. Now they use, so to say, for instance, some harvesters. And robotics, it shouldn't live on its own. We should be quite careful with the participation of the state and large business, but we will win, I'm sure. Okay, thank you all. Thank you all the speakers. Thanks to all our audience, to all our participants. I think it was quite interesting discussion. Thank you.